Hi friends, this online class is for plus 2 mathematics. We continue solving problems in maxima and minima of functions. There is a question solved in your text, NCERT text. Example 38. Prove that the radius of the right circular cylinder of greatest curved surface area, which can be inscribed in a cone, is half that of the cone. In the question, it is given that a cylinder of greatest curved surface area, it is specified. You are given a cone. Suppose you inscribe a cylinder in it to get maximum curved surface area. In that case, the radius of the cylinder must be half that of the cone. We have to prove it. I have given a diagram of the cone and the cylinder inscribed in it. The naming of the figure is something different from which is given in the text. Here I have taken two right triangles, POA and SRA. PO will be the height of the cone and SR will be the height of the cylinder. OA will be radius of the cone and QS will be radius of the cylinder. We have to formulate the curved surface area in a single variable. Let it be x. If we name the curved surface area to be s of x, a function of x, the curved surface area is base perimeter multiplied by height. Base perimeter is 2 pi into radius is x, 2 pi x multiplied by h. Then the surface area will be 2 pi x h. But you have to convert this h in terms of x. Here capital H and capital R, they are fixed. Now see, triangle POA is similar to triangle PRA. I think you have studied similar triangles. PO is parallel to SR. OA is parallel to QS. Angle POA is equal to angle SRA. Now, triangle POA is similar to triangle SRA, both right triangles. Now, PO by SR, corresponding sides, will be equal to OA by RA, corresponding sides. Now, PO is equal to H, capital H. See, height of the cone is given to be capital H We have assumed so. Height of the cone, capital H. Height of the cylinder, small h. Radius of the cone, capital R. And radius of the cylinder, small h. Now, PO is capital H, SR is small h, OA is capital R, and RA, this distance, RA is OA minus OR. OR is QS itself. Therefore, capital R minus X on cross multiplication, we will get a relation for H is equal to H into R minus X by R. Or HR by R is H, then minus HX by R. Now we can substitute for small h as H minus HX by R. Now, if curved surface area is S of X, 2 pi X H, H is H minus HX by R. Now, this is a function of X. On expansion, we can write S of X is equal to 2 pi Hx minus 2 pi H by R X square. That is to make it easier for differentiation. For maximum or minimum of a function, we have to get the first derivative, and when the first derivative becomes 0, at that particular point the tangent will be parallel to the x-axis such that the first derivative becomes 0. S dash x is equal to 2 pi h minus 2 pi h by r into derivative of x square is 2x. Then it becomes negative 4 pi h by r into x. For maximum, Sx, S dash x must be 0. That is 2 pi h minus 4 pi hx by r equals 0. Now, on simplification, this second term is taken to the right and we divide by 2 pi. You can divide by 2 pi h, dividing by 2 pi h on the left. It is only 1 on the right, 2x by r. That means r is equal to 2x or x is equal to r by 2. Now, we have to ensure it to be a point of maximum. For that, we have to fix that value in the second derivative and ensure that the result is negative. We shall find the second derivative. S dash x is so much, therefore S2 dash x, derivative of the first term is 0, but of the second is negative 4 pi h by r. That is negative 4 pi h by r. In this there is no x term. Suppose you find S2 dash x at x equals r by 2, you will get the negative 4 pi h by r itself. That is, at S2 dash x at a second derivative of that function, when x takes the value r by 2, the result is negative. It means that the curved surface area is maximum when the radius of the cylinder is half that of the cone. Okay? Thank you.